Okay, Algebra 1 students, in this video today we're going to be learning how to take a scatter plot and write a linear equation, okay? So with that in mind, please copy down your heading for today. We are going to fit a line to a scatter plot. Fitting a line to a scatter plot, please copy that in your notes. Lesson 5.4, please copy that in your notes. And copy down today's date so that your notes are organized, okay? Fitting a line to a scatter plot, lesson 5.4, and be sure and include today's date. Now, first, let's stop and quickly review what a scatter plot is, okay? So you can take notes on this if you want to, or just watch, okay? That's up to you. But here's a coordinate plane. Here's your y-axis. Here's your x-axis. Okay, now a scatter plot is when you have a bunch of points, like you might have a point here, and one here, 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 and here. Now that's called a scatter plot because you've got points all over, okay? Now, if you look at these ordered pairs here, guys, you can see, students, that they kind of go in the direction of a line, okay? Like this, okay? So what we try to do is we try to take this information, these dots, these ordered pairs, and come up with a linear equation. That's what we're going to do today. But before we do that, I want to review. Do you see what a scatter plot is? A scatter plot is a bunch of given ordered pairs like this. Okay, sorry students, I had to pause the video. I'm not sure exactly where I was, but a scatter plot is when you have a bunch of ordered pairs like this given to you on a coordinate plane, okay? And so these scatter plots can represent data from a business or information or whatever, okay? Now, so that's what a scatter plot is. Now notice, if you were to draw a line, it would kind of go like this, right? So I want to point out to you, we would say that this scatter plot has a negative correlation. You do need to know that, okay? Now why is it negative? Well, because think about it. Here's the left side of the line. Here's the right side of the line. Notice it's going downward from left to right, okay? So that scatter plot would have a negative correlation. You do need to understand that, okay? Again, you can take notes if you want to, or you can just listen right now, okay? Because I'm really just kind of showing you some little things before we get to the main part of the lesson today. What if a scatter plot looked like this? As you can tell, this scatter plot would have a positive correlation because the line would look something like this. Okay? And here's the left side, here's the right side, and the line is going upward from the left to the right. So this scattered plot here would have a positive correlation. That's pretty easy to see. It's not really difficult, okay? And do understand that some scatter plots, guys, would have no correlation at all, okay? And they would look like this, a scatter plot that looks like this. There really isn't any positive or negative correlation, okay? And that can happen. And you would simply say neither positive or negative correlation, okay? But the main thing I want to do is simply review what a scatter plot is before we continue on, okay? Now, please take some really good notes as I show you how to fit a line to a scatter plot, okay? Here we go. Please copy this problem in your notes if you would, please, okay? It's pretty simple material, so there's a very good chance I'm only going to give you one example. So that's very, very important. You take great notes, okay? I might give you 2 examples. We'll see. Let's put a point here, students, and here, and here. And we'll put one here, 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 and here, okay? Now, obviously, this is a scatter plot that definitely has a linear correlation, a negative correlation. You can see it kind of looks like a line going this direction, okay? Alright, So we're going to try to write a linear equation that somewhat represents the scatter plot. Now, just stop and listen for a second. You know, if you have a point here and a point here, you can easily write a linear equation from those 2 points. I taught you how to do that just recently in your last videos. We've been learning how to write linear equations, right? But here we have a lot of points and they don't line up in a perfect straight line. So what do? Are you listening? Listen carefully. You pick 2 points and use those 2 points to write your linear equation. However, please listen. If you pick these 2 points, that's not a good idea. Connect those 2 points with the line. Does that line right there going up and down correctly represent the scatter plot? Not at all. The scatter plot's going down like this. If you picked these 2 points here, would they represent the scatter plot? Well, not at all. Draw a line through those 2 points. That line there does not represent the scatter plot. The scatter plot looks something like this. Do you see what I'm saying? So when you pick 2 points, if you don't pick good points, I will take points off on tests and quizzes. So you want to pick 2 points so that when you connect those 2 points, the line goes decently down through the middle. So I would probably pick this point here and this point here, because if you connect those 2 points, you get a line that goes pretty much through the middle of the scatter plot, going the same direction. Do you see what I'm saying? I would not pick these 2 points, because if you draw a line through those 2 points, you get a line that doesn't even slightly represent the scatter plot. So, in your notes, let's go ahead and get an order. Let's go ahead and get these 2 ordered pairs. We're just going to kind of estimate. So we'll say 1, 2, 3, 4. 1, 2. So we're going to call this ordered pair right here -4, +2. This ordered pair here, we're going to call it 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So we're going to call this ordered pair +5, -5. Now let me stop and say something again, students. Are you listening to me? When I give you a scatter plot and you pick your 2 points, you must pick an intelligent set of 2 points. Like I said, guys, you wouldn't want to pick these 2 points here, because if you drew a line through those 2 points, it'd go like this. And that doesn't represent the scatter plot at all. Make sure you pick 2 points. Sorry guys, I had to pause the video again, but make sure your 2 points, when you connect those 2 points, gives you a line that pretty much goes down through the middle of the scatter plot, okay? Alright, so I've picked 2 points that are a good representation of the scatter plot, have I not? Sure I have. And now guys, I don't have to teach you anything. You know what to do. I taught you this in your previous lessons. I taught you how to take 2 ordered pairs and write a linear equation. Remember, first of all, here's the model that you're going to use. Remember, we learned how to do this in our past videos, okay? But you cannot use this model until you know the slope. You've got to know the slope. Okay, so let's find the slope real quick. Remember, y minus y over x minus x. Here we go. Here's your y, 2 minus a -5. So 2 minus a -5. Your first y is 2 minus, your next y is -5. X minus x. Your first x is -4. Then minus, and your next x is 5. So you get 2 minus a -5 is +5, that's 7. -4, -5, that's -9. So a positive over a negative is negative, and 7 nines cannot be reduced. So there, we found the slope. Now, remember I taught you this already. You pick one of these points. It here's my y, here's my m. Remember, the first y and the first x never get substituted out for a number. They stay y and x. So I leave this y, and then minus, and then what's my y value up here? -5. Y minus a -5 is y plus 5. Alright. Here's m. I'm going to put -7/9. And then x minus, and then my x is 5. And now let's finish this up. Remember, you're done when you take the 7/9 and multiply it through, and then bring your positive 5 over. So y positive 5 equals -7/9 times a positive x is a -7/9 x. -7/9 times a -5 is a positive 35/9. Okay? Now bring your 5 over and make it a -5. And we're finished. Your answer would be y equals -7/9 x. -7/9 x, and then this would be -45, -10/9. Now I'm going to show you where I got that in a second, okay? Alright, let me show you how I got this, alright? Let's clear off some space here so we can work. Okay, we have a positive 35 over 9, and a negative 5/1, right? This is 5. You can put it over 1 if you want to. So we're going to combine those. We're not multiplying, we're going to combine those. So a common denominator for 9 and 1 is 9. So this stays the same. One goes into 9. 9 times -5 is -45. Combine those and you get -10, positive 35, -45, -10/9. And of course a negative over a positive is negative. And there's your answer. Students, I promise you I'm not trying to rush through a video. It's just not really necessary to give you a lot of information because you know how to do this. Here's the main thing you're going to struggle with. You're going to struggle with picking two intelligent points. Well, I shouldn't say struggle because it's easy to do, but that's the only new thing we've looked at today is picking 2 points that really gives you a line going through the middle of your scatter plot, okay? And once you pick those 2 points, you guys know what to do because we've learned how to write a linear equation when given 2 points. Remember, we've learned how to write a linear equation when I give you the slope and the y-intercept. We've learned how to write a linear equation when I give you a point and the slope. And you've learned how to write a linear equation when I give you 2 ordered pairs. And that's what you have here is 2 ordered pairs. Okay? Alright. Now, finishing things up here, I want to quickly explain why this is good, solid, practical, and helpful math, okay? Please watch carefully. You might have a company and you're trying to predict sales. Now listen to me, this is very important. And let's say you have a bunch of data in 1 year. In 1 year, sale, in the first year sales were here, next year sales were here, next year, here, next year, here, next year, here, and next year they were here. Well, you can see that's a nice linear progression. So let me ask you a question. Would it not make sense? Let's say this is year, let's say this is 2015. 2016, 2017, 2018, 2019, 2020. If you wanted to predict sales, let's say in the year 2025, you could make a linear model. You could connect these 2 points right here, and they pretty much go through the middle of the pack. Or I guess you could also There's other 2 points you could pick. You could pick this point here and that point there. It doesn't matter. But you pick your 2 points that give you a good line, and you write your linear equation. And then let's say I'm just making this up, okay? Just bear with. Let's say your linear equation is y equals 5x. I don't know. Plus 10. Okay. Hold on, guys. My cell phone's going off. Let me turn it off real quick here. All right, now, so, what you can do is you can actually put in a number for 2025 for X and get out a predicted profit out here for the year 2025. It helps you predict. Now, it's not perfect, but it would help you predict what's going to happen in the future. Businesses use these types of models, linear models, all the time. And that's why it's important to know how to do this, okay? Alright, so that's it for today. I hope that makes sense. You should be able to take a scatter plot, pick out 2 good, solid, intelligent points that give you a good line that represents the scatter plot. Take those 2 points, write a linear equation, and then you'll have a linear equation like this. This linear equation right here. Now listen, it's not a perfect representation of this scatter plot, but it's a decent representation of the scatter plot. Okay? Alright, contact me if you have any questions.